Hey, welcome back, guys. In this video, we are continuing working with the type of indeterminate forms. Okay, and here we're gonna go ahead having some of the examples. With the sine and the tangent, maybe the cosine. So we're doing the examples. Let me just put it like this. Now we're gonna have our first example is gonna be we would need to find the limit when x goes to 0 of the sine of 11x over 3x. Okay, so now as you can see, you plug 0 in here, it's going to give you 0 and 0 there, so the form is 0 over 0. It's a perfect form to use the L'Hopital's rule. Okay, so what we're going to do is we're going to take a derivative. We're going to take a derivative of the numerator and also the denominator, and we're done with that. All right. So taking the derivative of the numerator, remember the sine, we can use the chain rule. Okay. Remember the chain rule. You can check it out in other videos. So this is going to give us the limit when x goes to 0, and the derivative of this one will be 11. And the derivative sign is cosine. And 11 times, hold on, it's look like doesn't look that good. Okay, that'll be here 11 times the cosine of 11x. Okay, and the whole thing divided by 3. Okay, the derivative of the denominator is quite simple, it's 3. All right, now what if we apply 0 in it? Okay, we put 0 here. If you put 0 in there, this is going to be the cosine of 0 is 1. Okay, this is going to go to 1. So our final result will be 11/3. All right, so the second example, we're going to take, we're going to be finding the limit when x goes to 0 of the tangent tan of 5x over x. Okay, so doing the same thing, this is a perfect 0, tangent of 0 here, the tangent of 0, 0, and 0, so we're having 0 over 0. So what we're going to do here, use the L'Hopital rule. Okay, we're going to use the L'Hopital's rule here. We take derivative. Remember, the tan is the cos is a sine, excuse me, the tan is the sine over the cosine. Okay, so we can write here, we can first turn it into that in this writing here by saying that this here is the limit when x goes to 0 for 10 here, so we're gonna have the sine of 5x over the cosine of 5x, and then over, oh, this is too close, and then over x. Okay, okay, and this is here just like a 2 division, right? This is just like this, like if we just imagine that there is a 1 here below. Okay, so this is going to give us therefore the limit when x goes to 0 of the sine of 5x. We're having 2 division, I mean we could turn that into multiplication. That's going to give us sine of 5x times 1 divided by x, cosine times cosine of 5x. So this is the first thing we can do. Just first write it like this. Okay, now let us check if it's possible to work it out. Okay, we plug 0 in there, it gives us 0. We plug 0 in there, it gives us 1 cosine of 0. Cosine of 0 is 1, and 0 is still 0 over 0. So this time we're gonna take the derivative according to the L'Hopital's rule. Okay, So just first make some rooms here below. Some, okay. So I'm gonna do like this, and to have more places to write. Okay. All right. Then I'm almost done. Okay. Gotta know. I can move this one here. Okay. All right. See here. All right. Okay. Now we're going back to our exercise. So we're gonna say that this here we're gonna take derivative. So it's gonna give us the limit x goes to 0. Derivative of the sine of 5x. This is exactly what we did here. Okay, that we use the same process to get this one here. So it's gonna be 5. Okay, and cosine of 5x, right? Okay, divided by, but here we're going to use the chain rule, okay, to do that. Remember, I mean the product rule, excuse me, the product rule. And the product rule is about, let me just show you quick. The product rule, first of all, just wipe this one here. Okay, write the product rule here. All right, okay, the product rule, I had it in my other video. It's like when you have u times v, okay, prime, it is u prime times v minus u times v prime. Okay, and that's what we're going to do here. So let us just, apply it. It's going to give us here the derivative of u of x is 1, okay, times the cosine of 5x plus the derivative of cosine is 5 sine, or the derivative of the cosine is minus sine. Let me show you. Alright, I had my other video when I was showing how to have the derivative. Just show it again. Okay, so the cosine, I mean the sine, sorry, the sine positive is here on the top. The positive, that's what I said. Okay, the cosine positive is right here. The cosine negative is on this side here, and the sine negative is here. Okay, the value we're having is a cosine. If you're here, when you're derivating, you're going this way clockwise. Okay, it means that our derivative will be minus. That's why this one here will turn into a minus. So we're gonna have here minus, okay, and minus 5 and sine of 5x times x. So times x, it means that I can rewrite it by saying that instead of writing this way, or I can say, let me just put it like this, can rearrange it times x, okay, and that's the whole thing. All right, so this is equal to the limits x, just rearrange everything, 5 times the cosine of 5x, okay, over the cosine of 5x minus 5x sine of 5x, okay, sine of 5x. All right, we got everything. Okay, now let us just plot the 0 in everything to see what it's going to give us. If I plot 0 in there, I'm going to have the cosine of 0, it is 1. So we have 5 on the numerator. If I plug in here, it's going to give me 0, 1 again here. And if I plug it here, it's going to give me the sign here of 0 will be 0 times 0 is 0. So we have 5 over 1. Okay, so everything's okay. So this is going to give me, if I plug 0 in it, it's going to give me 1. This is going to give me 1. And the whole thing here is going to give me 0. So my result will be Then I have the limits when x goes to, oh, this color is kind of shiny, I don't like it. Hold on. So this gonna be the limits x goes to 0. We don't need a limit anymore, but we don't have any x in it in the function in our terms. So this is going to give me, this is equal to, that's why I had to use that other column. This is equal to, of course, 5 over 1. Okay, and this is equal to 5. All right, so this is the result of these two other examples concerning the type of indeterminate forms. Okay, see you next with some other examples. Thank you for watching again. Bye bye.